All right, so number 9 says, I'm going to just do one last thing. We have y equals 2 over x plus 2 minus 3. All right, so let's start thinking about how we would make this look on a graph. This right here is going to tell us that our vertical asymptote is here. And then this one here is going to tell us that we have a horizontal asymptote down here. Okay, good so far with that? All right, so a few things to kind of consider. Do I have a negative sign out in front here? Nope, so that's going to be in this region and also down in this region, okay? And I'm just putting those dots just so we kind of keep in mind where it's going to be. Let's see. It appears that it will indeed cross the x and the y axis both because the asymptotes are both shifted off of there. So let's figure out where it crosses. So I'm going to go 0, comma, blank, and blank, comma, 0. So 0, comma, blank, that's obviously an x value. So I get y equals 2 over 0 plus 2. So 2 over 2 minus 3. So y equals 1 minus 3, which is negative 2. So 0, negative 2 is down there. And then let's do this one. That's a y value. So I'm going to go 0 equals 2 over x plus 2 minus 3. Add 3. And then I can move this over. So I'm going to get 3x plus 6 equals 2. Subtract 6. So x equals negative 4/3. So negative 4/3 is like here. And this one was negative 2. So here's where our graph looks like. And we're all done. Does that make sense?
Yeah.
So again, for the most part, when they're just like this, where it's a linear component as a denominator, so it's only x, it's not x to a power higher than 1. It's going to be a hyperbola that happens in opposite, we could say quadrants, but the quadrants aren't necessarily 1, 2, 3 because the asymptotes shift around. But that's basically what we do with it. What else did you see off of here that you need? More guidance and assistance and fun activities. Yeah.
It's more just like a general question, but you have to write like points for the other half of the graph.
No, in fact, if you are truly confident that you know what the points are, unless it asks for the x or the y-intercept, I'd say you just draw, just kind of a, just don't make them look like a parabola.
Okay.
Or some people will draw, hey, it looks like this. It's like, it's not quite that. Okay. All right, so I have a plan. So this is my plan. This is going to take place next week. Hey. Uh-huh. Yeah. Or you can have her come in here. Oh, jeez. It happens. All right, so next week, this is what my plan is, just so you know. Monday, we will do capstone review on Schoology. And this is the one, we'll do this in class. This is the one that has the videos on it. I will then give you a capstone review test on Schoology. Now, if you promise not to tell anybody, these two tests are the exact same test. top one has videos for answers. The bottom one doesn't. No, you can't use your notes on it. Okay? But if you pay attention on Monday and we go through get all your questions answered, you will see the exact questions that are on the end of the chapter. I'm using the capstone review that is not the video link as our last quiz. We will then take on Illuminate on Wednesday the actual capstone. Remember, I have to do it on the Chromebooks here. You can't do it from home. Illuminate doesn't open from home. And then Thursday, Friday, we will then have our review for the final. And let's see, help me out. This is period 3, so we have period 1, 2, and 5, 6, and then 3, 4. So I guess we would have this final on Wednesday. Is today Wednesday? Today's Tuesday. Jeez, I'm losing days. So 2 weeks from tomorrow will be our final exam. And it sounds like on your final exam, I will get you guys a 3x5 note card, and you can put whatever you want on that 3x5 note card. Be like most students, write in the font size that you can't see unless you have a magnifying glass. But that'll be what we have planned. Sound good? All right. So let's go back. Was there any other questions from the homework, or we feel okay? All right, let's go. Everyone have the notes packet? If not, I got a couple extras if you need one. I see Cole didn't bring his. I see how it is. Need one? There you go. Anyone else? All right, so this is 11G, Graphing Rational Functions, Part 1. Develop an understanding for graphing rational functions with linear parts. Linear just means that you don't have x squared or you don't have square root of x. You have x plus something or x minus something with it. And it's not a whole lot different, but there's just a couple of things that go into it. So rational function, you have a function on top, you have a function on bottom. The functions on top and bottom have to be polynomials, so the polynomials do not have a radical with them. So it's just a sequence of what we've been dealing with, but we put them together. So you have vertical asymptotes where the denominator is equal to 0. The graphs are hyperbolas, so they happen in opposite situations on the graph. You have a horizontal asymptote, whatever the k value would be. The domain and range deal with the asymptotes. That's what we'll be looking at, so we'll talk about that a little bit. But they're not impossible once you look at the graph. They become, hopefully, somewhat obvious. Okay, can I move on? All right. So, first graph, vertical asymptote is going to be x equals -5. So that's a vertical line at -5. Does everyone feel comfortable how I got that answer? I figured out where the denominator would be equal to 0. We plug it in, so I got 1, 2, 3, 4, 5. So I have a vertical asymptote over here. Okay. A horizontal asymptote is going to be related to this right here. So I have a horizontal at y equals 3. So 1, 2, 3. Okay. So we're going to have some sort of region that takes place, being that the vertical and horizontal asymptotes are off from the origin, or off the x and y axis. They will cross the x or y axis. Okay, so let's just figure out where they'll cross. And it's totally okay to just basically, once you know your asymptotes are taking place, use these two points or two items just to get it figured out. So this is obviously an x value, so you plug 0 in for x. We'll figure out the domain here in a second. So I get y equals 7 over 5 plus 3. So y equals, what is that? That's 1 2/5 plus 3. So y equals 4 2/5. And of course, you had a calculator. You could take care of that. So 4 2/5. So 0, 4 2/5. 1, 2, 3, 4 2/5 is just a little tiny bit up. Okay. And then the other one, that's a y value. So if I plug 0 in, I go 7 over 5, or x plus 5, excuse me, plus 3, subtract 3, 7 over x plus 5. That's supposed to be a 7. So then I get negative 3x minus 15, because I would multiply the x plus 5 to the other side, and I'm distributing, equals 7. Negative 3x equals, add 15, so I get to 22. So x equals 22 over negative 3. So think about that being negative 7 1/3. So negative 7 1/3. So negative 7 1/3. 1, 2, 3, 4, 5, 6, 7 1/3. 7 1/3, sorry. 7 1/3. All right, so I know that this graph is going to kind of look like this, going through that point, and this graph is going to look like this, going through that point. So the nice thing about how that one worked out is we figured out 2 separate points on each branch of the hyperbola, or hyperbola. Okay, now if I wanted to figure out the domain from this, okay, as I come, my domain goes from negative infinity to the blue line. The blue line we said was negative 5, and then it goes from negative 5 to infinity. So the domain has 2 parts to it. Okay, I get up to the asymptote, the blue asymptote, it shoots straight down it, and then it comes from way up, high, and down. And then if I wanted to say, what about the range? Well, the range are the y values. So if I come from bottom to top, the range will go from negative infinity to the green asymptote, which you said was 3, and then from 3 to infinity. So again, the domain and range have 2 parts to it, because it exists on either side of the asymptote. Okay? Does that seem okay? Yeah.
So the domain and range is just every number except for the asymptote line?
Yeah, every line. So the domain's everything except for the vertical asymptote, and the range is every line for the other than the horizontal asymptote. Okay? May I move forward? Stop fogging my glasses. Get rid of these masks. One day we'll be all gone. All right, so there is a chance that your rational function will look like a linear component over a linear component, or a polynomial over a polynomial, where it's not just a singleton number. So if this takes place, this is going to have a horizontal asymptote. I'm going to put a 1 there at 2 over 1. So y equals 2 over 1, which is y equals 2. Okay, that's the only thing that changes if it's the exact same degree on top as the exact same degree on bottom. So in this case, we have first degree on top, first degree on bottom. We develop a different horizontal asymptote. It becomes the lead coefficients of the thing. So if your degree on top is equal to the degree on bottom, you take the lead coefficient of whatever those highest degrees are. So if you had x to the 5th on top, if you had like 5, or let's say you had 4x to the 5th on top and 3x to the 5th on bottom, your horizontal asymptote would be 4 over 3. Doesn't matter what the rest of the problem is. You're just looking at the highest exponent on top and bottom. You realize they're equal. Whatever the coefficients in front of them are, it's that over that to get that. So a lot of times you get these coefficients like horizontal asymptote of like 1/2. So it's barely off the x-axis. Okay. We'll talk about that more. We'll get into more of this. All right, so first thing, vertical asymptote. What number do I plug in for the domain or the denominator that would make the whole thing 0? 2. 2, right? 2 times 2 is 4. 4 minus 4. So x equals 2 is my vertical asymptote. I get that. My horizontal asymptote goes like this. Okay, I have first degree. There's technically a 1 in front of that. So my horizontal asymptote, because of the degree on top and the degree on bottom, because we have a fraction over, or we have a 1 fraction only. We don't have it added to something else. We have just a fraction. You look at and say, okay, well, this is going to be 1/2. So our horizontal asymptote just comes straight along here. being that my asymptotes are not right on the x and y axis, I can now find that they're going to exist somewhere on the x and y axis. So if I had x, y values as points, I'm going to have 0, and I need to figure out that. I'm going to have a 0 down here. So it's the same work I had been doing. So if I plug 0 in for x, I'm going to get y equals 0 plus 1 is 1. 2 times 0 is 0. 0 minus 4 is negative 4. So I would get negative 1/4. So 0, negative 1/4 is like down here. Okay? And then if I wanted to find the other point, do this in purple. This is a y value. So if you plug 0 in for your y value, if I multiply both sides by 2x minus 4, I get 0 equals x plus 1. So x equals negative 1. So negative 1 comma 0, which is right here. So I only found on one side some points, but this tells me, hey, this looks like this. And this one, this branch over here kind of looks like this. You just try and make them look similar. Again, I didn't plug any points on this. I just kind of know that it shoots up and down the asymptotes. So the domain, negative infinity to 2, and then 2 to infinity. Again, you're using a rounded bracket on the 2's. That means that they don't equal it. The range, I'm going from bottom to top, so negative infinity to 1/2, and from 1/2 to infinity. That's our domain and range. Anna, what you got? Yeah.
Just reading.
So domain and range. Domain is this. Range is this. We doing okay? You guys getting excited? Summer's gonna come soon, even though it's like snowing today. Maybe we'll get a snowstorm in June too, just to mess with everybody. No? Okay. Well, it's funny when I call my friends in Arizona. I was like, hey, how's the weather down there? Oh, it's 103. What's it doing up there? Snowing? Oh man, are you kidding? It's like, yeah, that's what happens. All right, hey, may I move forward off this graph? This good? We're happy? All right. All right, so next problem. Vertical asymptote is where the denominator is equal to 0, so x equals 4. Horizontal asymptote, because we have a singleton fraction. I'm not adding or subtracting a number. If this is to the first and this is to the first, which they are, and I have a 1 in front of that x, it's going to be 2 over 1. So y equals 2, because 2 over 1 and 2 is the same thing. Sometimes it's hard to decipher in algebra 1. Is 2 over 1 the same thing as 2? Sometimes. Oh, okay. All right, so again, additional points. So I'm going to have an x and a y that I'm going to use that just down here. And I'm going to have a 0 for an x, and I'm going to have a 0 for y. And we're going to figure this out. So if I plug 0 in for x, I get y equals 2 times 0 is 0. 0 plus 3 is 3. 0 minus 4, so negative 0, let's see, negative 3/4. So 0, negative 3/4 is like here. Is that okay? And then if I wanted to find the other one, I'm going to go 0 equals 2x plus 3 over x minus 4. I'm going to multiply both sides by x minus 4, but x minus 4 is going to be multiplied by 0, so it's going to be 0 over here. So I get 2x plus 3, subtract 3, divide by 2. So I get negative 3 over 2. So negative 3 over 2 is like here. So I only got points on one side or one branch, which is okay, bless you. So this looks like this, and it looks like this. Anyone want to take a shot at the domain? To 4? 4 to infinity? Anyone want to take a shot at the range? to infinity. That's it, folks. Come on. 2 to infinity. Boy, these were supposed to be so complicated. Maybe they are. I don't know. Hopefully you're understanding them. Huh. May I move on? Or am I done? Let's see. How much more do I have? 4. This it?
Yeah.
This is it? That's it? Oh boy, this is hotcakes and sausage. Okay, vertical asymptote. What do you think? X equals 4? All right, x equals 4 is here. All right. Oh, this is a challenging one. Horizontal asymptote. Careful, it's out of order up top. 2x plus 1, right? That's what our top is. So I'd go -2 over 1, which is just -2. Agree? Is that what I had taught? I hope so. All right, again, because our asymptotes are offset from the xy axis, they will cross the x and y axis at certain points. Okay, so again, I have an x value, I have a y value. Plug 0 in here, plug 0 in here. Okay, so if I plug 0 in for x, I'd get y equals 1 over -4, right? So 0, -1/4 is like here, I think. And then let's plug 0 in for I try nice things and I goof up. All right, I'm going to plug 0 in for our y value. So I get 0 equals 1 over 2, or 1 minus 2x over x minus 4. Multiply both sides by x minus 4. So 0 times x minus 4 is this. Add 1, subtract 1, divide by -2. So it looks like 1/2. So 1/2, comma 0 is like here. So why did this one jump to the opposite regions? Yeah, this here made it jump. Okay, we had that negative in front. That made it flip-flop. So my domain, anyone want to take a shot at it? It's still going to be the same idea. -infinity 2, 4, 4 to infinity. Range, -infinity, what's the green line? Yeehaw, -2 to infinity. Oh, I feel so good about this stuff. You're like, you would. No, I think you guys are okay with this. A lot of homework, sound good? Like 55 problems? Nah, I don't think we should do that. I just think we should deal with some graphing. Holy moly guacamole. Wow. Front, back, front, back. All right, how about we do, what am I on? G? Let's do 11G. And let's do 9 through 15 odd. It's got the graphs, it's got the domain and range. But that's what I got. And I'm done early. Woohoo! See you guys later. Am I done early or is it like time to go? Oh man, we got all kinds of time. All right, so I'm going to put that down there. I'm going to hit freeze here. Always. Now I can stop recording.